Fourth unit is two variable calculus. The syllabus contains limits, continuity, partial derivatives, total derivatives, maxima, minima, and saddle points, method of Lagrange multiplier. So first we see limits. 2.1 limits. Here we deal with two variables. So the function f of x comma y tend to limit L as x tends to a and y tends to b if and only if limit L is independent of the path following by the point x comma y as x tends to a and y tends to b. So whenever the point x comma y tends to the point a comma b, x comma y is any random point in a curve. So when it tends to a comma b, we get the function tends to value L. Then L is called the limit of the function, and we say the limit exists. So in other words, if we say for a given epsilon greater than 0, we can find a delta greater than 0 such that modulus of f of x comma y minus L is less than epsilon for x comma y in x minus a the whole square plus y minus b the whole square less than delta square. That is, whenever x comma y tends to a comma b, for all the points lying inside the circle with center a comma b and radius delta. So for any epsilon greater than 0, if we are able to find a delta greater than 0 such that all those points lies within the circle with center a comma b and radius delta. So how normally we write this on means there are three forms of writing this. Limit x tends to a, y tends to b, f of x comma y equal to L. This is one way of writing. And another is limit f of x comma y. We can write x tends to a, y tends to b as points. Okay, so x comma y tends to a comma b. So the point x comma y tends to the point a comma b. That is equal to the limit L. Another way of writing is separately writing limit. Limit x tends to a, limit y tends to b, f of x comma y. So when we say a limit exists or not means there are conditions. That is, the function takes the value L independent of the paths from x comma y to a comma b and y comma x to b comma a. So there we consider two paths. For one variable, we consider left limit and right limit. Here, the paths are considered. Okay. So limit may or may not exist. There is not a condition that all the functions should have a limit. Limit either exists or not. We are there to identify whether limit exists, and if it is existing, what is that limit? And if it exists, the limit must be always unique. Okay, a function cannot have more than one limit. So there are working rule for the problem. So see the step 1, we consider the limit along path 1. Path 1 means from xy to a comma b. Okay. So limit x tends to a, y tends to b, f of xy. We need to find this limit. Step 2, along the path 2. That is, we find the limit. See the changes. Y tends to b, then x tends to a, f of xy. Here x tends to a, y tends to b, then we change. Here x tends to a, y tends to b means first we substitute for y tends to b and then for x tends to a. Or x tends to a, then for y tends to b. Here the other. First we substitute y tends to b, then x tends to a. Like that. So if in the step 3, if we find the both the limits what we have found in path 1 and path 2 are same, then we say the limit exists. If they are not equal, then limit does not exist. This is for x comma y tends to a comma b for any point. Suppose instead of a comma b, we have the origin. That is, any random point x comma y tends to the origin means the procedure differs. There we have to additionally find the limit for along the path y equal to mx and y equal to mx power n. So if we find along these two paths, then in all the four limits, the limits are taking same value, means we say limit exists. At any value, it is not satisfying the same condition, means we say there is no limit. That means specify step 1, step 2, and with respect to y equal to mx and y equal to mx power n, the in all the paths, there are four paths, no? With this one, path 1, path 2, y equal to mx means another path, y equal to mx power n another path. So four paths, it should take the same value. Then we say it is limit is existing and the same value is the limit of the function. So if it is not satisfying in this case, wherever it is not satisfied, at that step we can stop, saying that limit does not exist. Okay, we see some results regarding this limit. So if we have limit of f of x comma y, x comma y tends to a comma b, and limit that is L, and limit of g of another function, g of x comma y, x tends to a comma b for the function g of xy, which is which we find as m. That is limit of the function f and limit of the function g, both are same when x comma y tends to a comma b. You should see this x comma y and the limits are from the way, say, between the same variable points. That is, the approaches are same. So only the function differs. So under this f function, we are getting one limit L. Under g function tends to the limit m. Then the sum or subtraction of the functions, that is f plus or minus g. Just we don't want to find. If we know the limit of f and g with respect to x comma y tending to a comma b, then directly we can substitute the limits instead of finding the limit of the particular f plus g or f minus g. So just we can add and subtract the limits of the particular functions. Similarly, limit x comma y tends to a comma b, f into g can be written as directly as L into m. You can expect 1 mark questions or 2 mark questions under this. Limit x comma y tends to a comma b, f divided by g equal to L divided by m. Here, with respect to the condition, m should not be equal to 0. That means the limit of the function which is divided should not be equal to 0. So it is meaningless. If m equal to 0, the limit is meaningless. Okay. So only if the denominator function has non-zero limit, we can consider this division of the functions. Okay. We go for the first problem. So the type 1 problems are when a comma b not equal to 0, comma 0. That means when the point is not origin. This is too simple problem. If you look into the working rule, see, up to this, the not a comma b not equal to 0 condition. If a comma b equal to 0, then only we need to find for y equal to mx and y equal to mx power n. Remember, okay, so the point a comma b is non-zero, not origin point, means we can stop with these two steps. Okay, so here first we see a comma b not equal to 0 comma 0. So we have to find the limit in one path and another path. If the limits are same, then we say limit exists. If not, limit does not exist. See the question, evaluate limit x tends to 1, y tends to 2. The function is 2x square y by x square plus y square plus 1. So how we do? Do along with me. So we consider the function as it is. X tends to 1, y tends to 2. 2x square y by x square plus y square plus 1. Now I substitute x tends to 1. I apply x tends to 1. That means instead of x, I substitute 1. So when I substitute x equal to 1, I should not write this x tends to 1 here. Okay, when I go for applying this value, I should not write x tends to 1. So instead of x, we substitute. So 2 into 1 square into y. Only for x we substitute. Okay, so here 1 square plus y plus 1. Here y square plus 1. So how it comes? 2y by y square plus 1. That is, again, if you are writing by simplification, means limit y tends to 2. Now I am not applying y. So I have to write this. Okay. So 2y square, I am just simplifying. 2y by y square plus here 1 plus 1, that is 2. Now I substitute y. When I substitute y, I should not write this limit. Okay, remember that. So when I substitute y equal to, y tends to 2. So 2 into 2, that is 4 by 2 square, 4 plus 2. So I get 4 by 6. By cancelling by 2, we get 2 by 3. So here the writing is very important. Whenever you substitute the particular limit, you should not write. But don't forget to write when you substitute for x equal to 1 the first variable, when you are substituting, the other variable should be written. So when you go for substituting the second variable, should not write that limit. So write and practice. Okay. So here how can we do? Here y tends to 2 first. So I substitute y tends to 2 first. Then I come to x tends to 1. So I plan to substitute y equal to 2. Therefore, I don't write y tends to 2 here. Okay, just I write x tends to 1. Now see, I substitute y equal to 2. So 2 into x square into 2. Instead of y, substitute 2. So here x square plus 2 square, that is 4 plus 1. So when I simplify, I write again for the sake, so limit x tends to 1, 4x square by x square plus 5. Now I substitute x equal to 1. When I substitute x equal to 1, I should not write this limit. Okay, directly I substitute. So 4 into 1 square by 1 square plus 5. 1 square is 1. 1 square plus 5. That is, we are getting 4 by 6. Simplifying 2 by 3. So now we find both the answers. The first path, along the first path and the second path, both are same. So we get from equation 1 and 2, limit x tends to 1, y tends to 2, 2x square y by x square plus y square plus 1 is 2 by 3. Since the limits are same, we consider the limit exists and that limit value is that particular value. Okay. Now see, evaluate limit x comma y tends to 1 comma 1. We can write in this form also, already I told. Function is x into y minus 1 by y into x minus 1. Sincerely substitute. Now I consider in this form. The path 1 form is x tends to 1, y tends to 1. Here both are 1, 1, so no issue. Only the order we should change here in the second path. So now I substitute x equal to 1. So what happens? Limit y tends to 1. Instead of x, you substitute 1. 1 into y minus 1 by y into 1 minus 1. Okay. So 1 minus 1 is 0. So denominator is 0 means it is always 0. Even you don't want to go for substituting this one. Anyhow, we can see how it comes. Okay. So this is equal to y minus limit, by simplify, limit y minus 1 by 0 into y. 0 into y is 0. Okay. So I didn't substitute y equal to 1. So just I take this one. Therefore, what happens? Y minus 1 here. Don't want to substitute even y equal to 1. When we find some value by 0, it is always infinity. So this is infinity. Okay, we know any number by 0 is always infinity. So don't want to, without going for substitution of y, we can conclude the limit is infinity. Now let us see when the other path, along the other path, that is, if we change the order, limit y tends to 1 and x tends to 1, the same function x into y minus 1 by y into x minus 1. Here we need to substitute y equal to 1 first, then x equal to 1. So when I go for substituting y equal to 1, I don't write y equal to 1, y tends to 1. Just I write x tends to 1 and I substitute instead of y 1. So what happens? X into 1 minus 1. Instead of y, I substitute 1. X into 1 minus 1. 1 into x minus 1. So here what happens? So when I simplify, limit x tends to 1. I haven't substituted x equal to 1. So I have to write this one. Okay. I'm just simplifying. 1 minus 1 is 0. Therefore, 0 into anything is 0 by x minus 1. Here also we don't want to go for the next step because 0 by anything. Here remember, 0 by anything is always 0. 0 by anything is always 0. So in this case also we can stop here and conclude that the limit is 0 here. So what happens? By equation 1 and 2, both the limits are different. So we can say limit x comma y tends to 1 comma 1. X into y minus 1 by y into x minus 1 does not exist because the limits are not equal. Does not exist. So we understand that it is not necessary for all the function to have the limit. No, not necessary. So if the limits are along the two paths, the limits are varying means the limit does not exist for that function. Now we cannot say the function has no limit at all. It is with respect to the point and the approach. When x comma y tends to 1 comma 1, it has no limit. Okay. Next. Evaluate limit x tends to infinity, y tends to 2, xy plus 1 by x square plus 2y square. Now you can do, I think, limit first path, limit x tends to infinity, y tends to 2, xy plus 1 by x square plus 2y square. Now I substitute x tends to infinity. So what happens? Infinity into anything. Infinity into anything or infinity plus or minus anything is always infinity. So when I substitute x equal to infinity here, I get that numerator as infinity and denominator is also infinity, isn't it? When I substitute x equal to infinity, both the values goes infinity. So this is called an indeterminate form. There are so many indeterminate forms, that is undefined forms, infinity by infinity, 0 by 0 and infinity by 0, 0 by infinity. So many infinite terms you could have learned in lower classes on L'Hospital theorem. So you should not do like this. So how you consider as infinity is in the numerator, whether we say the function is the value is infinity, or when the infinity is in the denominator, normally 1 by infinity or 1 by infinity is always 0. A by infinity, if any value by infinity is 0. We saw here any value by 0 is infinity, 0 by any value is 0, and another case is any value by infinity is always 0. So all these points are noted, okay? So how can we say whether since infinity is in the numerator, whether this value is infinity, or in the denominator infinity, whether it is 0. So that is, there comes an undefined state. So we should not do in this form, okay? The working procedure is different. How we do here means, suppose you are substituting directly means you should understand, okay? We are arriving at an undefined form, so it should be done in another way. What we do means, just we consider this, we take this x from both numerator and denominator, x outside, okay? So what happens? Limit y tends to 2. So here I'm not substituting x. So until I substitute x, I should write the same. X tends to infinity. Whenever I go for substituting the x, I should not write. Okay, so I am not substituting here first. So I write x tends to infinity and y tends to 2, I'm bringing out the given function in another shape so that it do not lead to indeterminate case. So what I do means, remember, I take x from the numerator common out and x square from the denominator common out. So what happens if I take x outside? What will I get? Y plus, there is no x in this term. So we divide by x. Remember? So 1 by x. Here I get 1 by x. Okay. Similarly, if I take x square outside here, in the first term there is x square. So when I take out, actually we divide, when we take x outside, that means we divide each term by x. That is the understanding, no? So here, if I take x square outside, I divide each term by x square. So what happens? X square by x square is 1. And the next term, there is no x term. So we write 2y square by x square. Be particular in this, understand and try to do. Okay, whenever we get undefined condition, we have to make this rule. We need to take the common factor, the variable as a common factor outside, and we substitute. So here now I try to substitute x equal to infinity first. So what I get, I try to substitute x equal to infinity. So I should not write x tends to infinity. I just write y tends to 2 because I plan to substitute for x. So here we can cancel this x and this x, only this side the x remains 1x we can cancel. So what happens when I substitute x tends to infinity? Here y plus 1 by infinity. 1 by infinity is what? 1 by infinity is 0. Okay. So anything by infinity, remember all these things, the 4 conditions. Anything by 0 is infinity, and 0 by anything is 0. Anything by infinity is 0. Note this. So 1 by infinity is 0. By, here we get x. Now I am substituting x equal to infinity. So I get here infinity into 1 plus 0. Because 2y square by infinity is 0. No, anything by infinity is 0. But I substitute here x equal to infinity. Now we get infinity into anything is infinity. So I get y by infinity. So 1 by something by infinity is again, it is 0. So very carefully you have to do. Okay. So try in this second path. Now, in the second path, we change the order. No, first y tends to 2 and x tends to infinity. Function remains the same. Now, I tends to apply y equal to 2 first and then x tends to infinity. So, I don't write x tends to 2 here. Just I write x tends to infinity because y equal to 2, I am going to substitute. So, x into y, that is 2x. Instead of y, put 2 plus 1 by, instead of y only we are substituting. So x square plus 2y square. Y square means it is 4. 4 into 2, 8. Now I need to substitute. Whenever infinity, the thing comes, any value, any variable x tends to infinity or y tends to infinity, please apply this method. Okay, take the variable common factor as and then substitute. So that directly if you are substituting x tends to infinity means the problem goes wrong. So here I get x tends to infinity. So what should I do? Again, I have to take the x value x as common. Okay. So if I take x common, until I substitute, I have to write this limit x tends to infinity. So just I am going to make a modification in the function. So I'm not substituting x equal to infinity. So I write limit x tends to infinity. So I take x again common from the numerator. So if I take x common from the numerator, divide each term by x, so that 2 plus 1 by x. Similarly, in the denominator, if I take x square common, we get 1 by x square, that is 1 plus 8 by x square. Again with the same condition, anything by infinity is 0. So these two terms become 0. So what happens? We get, now I substituted x tends to, when I substitute x tends to infinity, now see what happens. Here we can cancel 1x. Okay, so we get 1 by x. And if I substitute, now when I try to substitute x tends to infinity, I don't write this limit x tends to infinity. Immediately I am substituting. So here 2 plus 1 by infinity is 0. By here infinity, instead of x, I substitute infinity into 1 plus again 0. So what I get? Some 2 by infinity. 2 by infinity is 0 again. So in both the cases, both the paths, along the two paths, we are getting the limit as 0. So we say the limit exists and the limit of this function, the particular function is 0. From 1 and 2, we say limit exists for this function and the limit is 0. So do and practice this problem, and you can note these problems as homework and solve it and come. So evaluate the following limits. First problem is limit x tends to 2, y tends to 3, x square plus y square by 2, x square y. Second problem, limit, I have written just in the different forms. All are same, okay. X, instead of writing in this form, I have written x comma y tends to 1 comma 2. All are same. So limit x comma y tends to 1 comma 2, x square plus y by 3x plus y. Third problem, this also same. We can write in this form also. Limit x tends to infinity, limit y tends to 3, 2xy minus 3 by x cube plus 4y cube. So here and all, no issue. If you substitute and if you are getting properly the same value, then you conclude that limit exists, otherwise not. And you can here in the C problem, and we are getting x tends to infinity. So do this carefully by the previous problem, okay, in the idea of previous problem. Thank you.